Hello everyone, today I have something very interesting to show you about trigonometry. So I've been thinking about, you know, the typical unit circle. So let's just draw the function of the unit circle for now. But I'm just gonna draw the half of the unit circle to make y the subject and y as a function of x. So unit circle, it would look like this, right? Half of unit circle, yeah. Now I'm just gonna write here. Yep, we're gonna be differentiating half of the unit circle. Now this, I already worked it out. It's equal to minus x over this, the thing itself. So this, if you just think about the derivative of the unit circle, you know what we learned from calculus 1? Yeah, calculus 1. What's the slope here? Positive infinity, right? So let's just do a little bit of this. What's the slope here? Middle, like here. What's the slope here? 0. So let's do that. What's the slope here? Same as here, but negative. And then the slope here, negative infinity. So let's connect all the dots. Oh, isn't that interesting? Isn't this very, very similar to the very well-known tangent curve? If you plot this graph, the derivative, into, I don't know, Wolfram alpha or whatever you want, you will get this exact thing, and it looks almost exactly the same as the cotangent graph, or just a mirrored version of the tangent graph. But if you plot it together with a tangent or cotangent graph, you will see that it's not exactly the same. The curves are not exactly the same. The shape is the same. It has the same shape. It has the same shape, but like the curve and the steepness is not exactly the same. But because it's so similar to this cotangent graph and the tan graph, you know, the tan graph, because it's so similar, I thought, why is it so similar? Well, if you think about it here, let me remove this first, and let me redraw. If you think about the circle, right? Unit circle. Oh, I'm so bad. Okay, here. Tangent is sine over cosine, which sine is the y position, right? And then cosine is the x position of the unit circle. So let's say like here, and let's call this theta. This would be sine, right? Sine would be this one. So that's sine theta, right? And then this would be cosine theta, as usual. This is the length. Now this is 1, obviously, because it's a unit circle. But what is this? Well, if you change, this is 0, 0, right? The change of y minus sine theta over change of x minus cosine theta, that's actually the tangent theta. So this line, the slope is actually tangent theta. Now if you think about it, this has a tangent line as well. I know the names are a bit confusing, but there's a line tangent here at this exact spot, and this line is perpendicular to this line. And what that means is it has the slope of negative of the reciprocal of this slope. Negative, if the slope of this is tangent theta, negative reciprocal would be the slope of this, which is minus cosine theta. Cotan theta. Sorry about that. Minus cotan theta. Now, this relies on the angle, right? We want to know what the slope is here. This is like differentiation, if you think about it, because we're trying to know the slope on any point of the circle, and we can by using the angle. But what if we don't want to use the angle? What if we want to use the x value like this? Let's say I want to know here, like this, and we don't talk about the angle anymore. We just talk about this spot. what's the derivative here when I give you the x coordinate and not the angle? Well, we just did this. The derivative of the unit circle is this. We plug in the x coordinate and we get it. But how do we connect these two? If we say they're exactly the same function, but this is polar and this is coordinate, and this is Cartesian, then, well, I know it's not like exactly polar or Cartesian like that, but like, you know what I mean. This is angle dependent, this is Cartesian x coordinate dependent. So how do we connect them? Well, as I said here, and as we probably know, this length is cosine theta, and it is the x coordinate. So this is actually x is equal to cosine theta, right? So this right here, the angle here would have to be related to the length here, which the length here would be cosine theta, as I said. So what we can do is just substitute this into there. So what do we get? Let's see. Minus x is cosine theta, so this is right cosine theta, and then over square root of 1 minus cosine theta squared. That is just sine theta, because 1 minus cosine theta squared is just sine theta squared, and then square root of that is just sine. Minus cosine over sine is, yes, minus cotangent theta. They are indeed the exact same function. That's why they have such a similar shape, and it is literally the same shape because they are the same function. It's just that one of them relies on the angle to find the derivative, or not derivative, relies on the angle to find the slope, while the other one relies on the Cartesian x coordinate to find the slope. That is it. This is what I've discovered. It was amazing.